Hello everyone. So today we are going to solve another interesting problem number 480, sliding window median. And it's a problem from hard category, but it's not really that hard. The problem says the median is the middle value in an ordered integer list. As we know, if the size of the list is even, there is no middle value, and we calculate the middle value by summing the two middle elements to get the median. And if it's odd, then the median is the middle element in a sorted array. So we are given an integer array nums and an integer k. There is a sliding window of size k which is moving from the very left of the array to the very right. You can see the k numbers in the window. Each time the sliding window moves right by one position, return the median array for which window in the original array answers within 10 raised to minus 5 the actual value will be accepted. Okay, so we have been given this array of size k. So we have 1 3 minus 1 minus 3 5 3 6 and 7, and we have a window, right, of size k. So let me make the window. So this is the window of size k, right? Here k is 3. So this is k is equals to 3, and if I sort this, then this become minus 1 1 and 3, and the median is the middle value, so the middle value is 1, right? Similarly, if we move the window from here to here, I just want the window. So if we move the window from here to here, then the middle will, and if we sort them elements, so it becomes minus 3 minus 1 and 3, and the middle value is 1. So the median is 1, and we are going to collect the value in the similar manner and return the answer. So this is the approach for solving this problem, and we are going to write the code in the similar manner that we are will create one array of size k, and then we'll sort this array, and once we have sort, then we'll add the incoming element and find median, and after that we'll remove the outgoing element, and collect all our medians, collect all the medians, and return the answer that we are looking for. So since it's a straightforward approach, we can, so this would be the brute force approach, and this brute force approach is not going to be accepted, is not getting accepted because it shows time limit exceed. So we'll modify our answers to solve this problem using the logics that I'm going to show you. So let me first write the brute force approach, and I'm going to discuss the other solution as I move along. So this is the brute force approach that I'm going to type out so that you can see that we are building the solution out of the very own solution that we have. So first we need the length of the array, and we'll make our current array up till the k minus 1 because I'm taking only the first two elements, and then I'm going to add the incoming element and remove the outgoing element. So that is up to k minus 1, right? And we need one medians array to hold our answers, and now we are going to traverse in the range from k minus 1 to n, and as we get inside we'll add the incoming element, so that would be from the right hand side, so that is the value of I, and we need our window, so the window is the sorted array, that we are going to have, and then we just compute the median. So this is, I'm computing the median. So if the value of k is odd, then the median is the middle value. So we need medians dot append, and we'll add the middle value of the window array that we created. Otherwise, if it is even, then the median is the sum of the two middle window elements that we are having. Window plus the previous element from the middle. So that is window k divided by 2 minus 1, and we need these two values together. So that by 2. So this is our median, and now we have the median, we need to remove the outgoing element as we are moving forward in the array to keep our window of the same size, and in the end we'll just return the medians that we have all the medians that we have collected. Now let's run and see how is our solution. So you can see it has been accepted, and let's run it for all the example test cases. And if I test it for even values as well, it's going to pass because that's the sliding window technique that we have written. So it says the function object has no attribute append. Oh, it's medians, not median. So it's going to be accepted. Now when I going to submit, this solution will show me time limit exceeded because it's not optimized, and Leetcode has specially made this problem not going to pass in this manner. So it says that it has not been accepted, and the test case that not been accepted was, I'm going to see the check. So this is the last test case of the 43 test cases, 42. So we have to modify our solution. Our solution is pretty good. So what I'm going to do is I'm going to really improve my solution, and to improve the solution, what I'm going to do is, as we are traversing, one thing I noticed that this is one advanced way of calculating median, that instead of all both of these, like looking for odd and even values, what we can directly do is we can calculate median just in one step by doing this. Like median is where am I wherever I'm in the middle, plus the using the tilde operator, we can calculate the middle previous value k by 2, and we're going to divide this by whole just by 2. So if it is odd, so if our median comes out to be, if k is odd, let's say 3, and the medians come out to be, or the first value I'm checking, and if the median come out to be, so here the median is minus 1, 1 and 3, so the median is 1. So k divided by 2 will give me k is 3, so it will give me the quotient of 1, and window of 1 will give us the value for 1, and plus similarly tilde is basically nothing but minus 1. So if it is I, so minus 1 minus I, so tilde of k by 2 will give me minus 1 minus k by 2, which is k divided by 2 was 1, so this is minus 2. So minus 2 from here, if we are seeing in the array, the minus 2 value is again this. So minus 1 plus 1 divided by 2 will ultimately reach to the center value, mid value of 1, and it will give us the median value for this window as 1. So we can reduce our code of this much portion of code to just one line of computing the whole code. And what we are going to do is now is we are going to use one container uh, called sorted list from the sorted container library to compute our sorted list values in the given array that we are going to have. So that I'm going to show you how we can improve that. So for that we need for, so this is the second solution that I'm going to show you. But before moving to that, the brute force has a time complexity. I want to discuss the time complexity for the brute force solution. So the time complexity for the brute force solution is, this is O of n minus k plus 1 for the for loop that we are having, and times since we are sorting, so that sorting is also taking O of k log k. So in total this solution has a time complexity of O of n log n k log k, right? And after this we are going to move toward our improved solution. So that is the second solution, improved. Let the name of that solution is sorted key list. So what we are going to do is we are going to use one library sorted list. What it is going to do is it is going to do our similar job that we are doing to pass our test cases. So the container where this is stored in Python is it in sorted containers, and we want from there we want to import the sorted list library that we are going to need. So from sorted containers, it is from sorted containers, and all we need to do is instead of array we are going to get our window directly. So we'll say that this window of mine is nothing but the sorted list of k minus 1 element, right? And everything remains same. So in the window we are going to add the incoming element nums of I and calculate the median like I discussed. So the median technique that I showed you of computing, so let me write it in a nicer way. So this is window of a divided by 2 plus window of tilde operator using the tilde operator and k divided by 2, and in the end just I'm adding those two values together, and I want to add all these value into my medians array that I have calculated. And this is once we have added the window, and now we need to remove the outgoing element from the end. So what we'll do is we'll simply do window dot remove nums of I plus 1, since we are one step ahead of the k, and we are going to remove that k minus k element. So currently initially I is still here 1 3, so I was 1, and once we add that, so I becomes 2, and we need to remove the outgoing element 1. So that is I plus 1 is 2 plus 1 minus 3, which is 0. So we are removing that element from the left. Now this is the simple operations that we need to do. So here we need to improve our sorted list like this. So this is nums of, we are going up till k minus 1. So if I show you how this looks in the windows, if I do print window, it will show you the correct window sorted list container that we are going to use. So now let's run our code and see how this is accepting. So as you can see that the sorted list which we are looking for initially in the brute force solution is -1 1 3. So this container also does the same thing, but internally it uses uh, multi-set functions for Python libraries, and this improves our uh, time complexities because inserting or removing element from a sorted list takes of log k solution. So time complexities, talking about time complexity, so time complexity of sorted list container is O of log k, and we are traversing in the uh, in our loop, so that is again O of n minus k plus 1 time, and then times the log k solution. So of log k multiplying those two together will give our time complexity to be O of n log k. So this is a very much better and improved solution over built on or top of our brute force solution. Using the same logic of the brute force solution, I've come out with this solution, and let's submit our solution and see how it performs for all the test cases. So it has been accepted and it's really faster. And if you really want to check out one more advanced solution that I have come up with, then it's the solution that I have come up with more base uses the inbuilt function of Python. So I can also show you that, and let's also dive deep into that solution. So what that solution do is, so this is, I'm discussing the third solution using the inbuilt functions of Python. Inbuilt functions. So so this is the third solution that I'm going to discuss now. So what I'm doing is, so what we'll do is we'll sort our elements the way it was. So initially the array that we have, so the array that we are having, so this is the array 1 3 -1 -3 5 3 6 and 7. And what we'll do is we'll pick our window. Simply we'll do is just pick our first window of three elements, 1 3 and -1. And that what I'm going to do is I'm going to sort this. So this sorting will make this as -1 3 and 1, -1 1 and 3. And that what I'm going to do is I'm going to use the remaining element, these remaining elements, and pair up these elements with the previous elements. So pairing will make me the tuples in this form. So I will have 1 and -3 3 and 5, then -1 and -3, -1 and 3, and then we'll have -3 and 6. Also we'll have 5 and 7, and in the end we'll have 3 and 0. So we'll need to add one more extra element in this remaining nums of up to k plus 0 to match up the pairwise pairing that we have. And once we have this, from here we can easily calculate our median and add that median into our solution and remove the element of the first element of the zipped functions that we have, zipped element that we have, and add the incoming element in the method. So that solution looks like this. So all we need to do is, the first we need to sort it out, sort out our get our sorted nums element up till k to make our window. So this window is now 1, minus 1, 1 and 3 for the very first time, and we need one medians array to collect our list. And what I'm doing now is I'm collecting all my pairs using the inbuilt zip function of the Python library. So that will give me the pairs that I'm looking for, plus the 0 for any non-matching, just to keep my loop running. That's why I'm adding this 0 in the end. And now what we'll do is we'll calculate our median like we discussed. So this would be window k divided by 2 plus window and tilde k divided by 2 and the whole divided by 2. So this is the advanced way of calculating median, and then all we need to do is append that medians into our median list. And from the window we'll remove the ongoing element, which is nothing but the first element of the zip values, and will now we need to add the incoming element. So for that we'll use the bisect insert method, so that will add our incoming element b in the window that we are looking for. This method is the same like we discussed of the previous method that I showed you. So just it is using the all the inbuilt functions from the Python libraries, and here we are not doing anything manually. We are using all the libraries of the Python to do our task, and in the previous solution we are doing all the things manually. So that's why this approach is an advanced solution on built on top of the manual solution that I discussed before. So now let's run our solution and see how it performs. So it has been accepted, and let's run it for all the solutions. So it has been accepted and it's running faster. So this was the solution that I have discussed first. Okay, so these are the three different techniques for solving this sliding window median, and it's a hard category problem, but as I told you, if you keep your focus on the fundamentals, then coding is not that hard. It's really simple. So I hope you guys are liking my solution. Thank you, and I will see you tomorrow. Please like and subscribe to the channel. It helps the channel to grow, and it helps me to reach out to you with new such awesome algorithmic solution. And I hope I am helping you guys in your interview journey. Thank you, and let me know if you have any particular problem request. I will have a look. Bye bye. Till then, take care.